Right now, at this very second, something strange is happening billions of kilometers away from you. No one sees it, no one hears it, but the signal is already heading toward Earth. Scientists are detecting it, trying to decipher it, and can't give a definite answer. It's not a stellar flare, not radio noise, and not even an equipment error. It's something that comes from the very edge of our solar system, from where the sun's influence ends and the real cold alien space begins. And most disturbing of all, this signal is being transmitted by an object we sent there ourselves decades ago.
Wherever you are right now, whether in the scorching heat of Africa, among the harsh archipelagos of the Arctic Ocean, or in the mystical Himalayas, look up at the sky. It is adorned with a magnificent necklace of trillions of stars, but there is one spot unrelated to the stars that cannot be seen with the naked eye. This is the most distant man-made object from Earth. We are talking about the American space probe Voyager 1, launched in 1977. Do you think it's been silent for a while? You're mistaken. The probe is still sending signals to Earth, and sometimes they puzzle astronomers all over the world. For example, recently Voyager 1 picked up a steady hum of unknown origin. What could this mean? Astrophysicists are still puzzled. What missions is Voyager 1 supposed to accomplish? And where is it now? The main mission of the spacecraft was to study the giant planets Jupiter and Saturn. It is worth noting that Voyager 1 completed its mission with flying colors. It was Voyager 1 that gave the world detailed images of the huge celestial bodies made of swirling gas, as well as their rocky moons. But that was only the first stage. The most difficult part was still ahead for the probe, and it began its crucial mission only relatively recently. Voyager 1 was given a huge responsibility to study the Kuiper Belt and the boundaries of the Heliosphere. But how can the collected data be interpreted if no one has ever been to such distant regions of space from Earth before? In a way, it's like traveling with an incomplete guidebook, where the majority of the information is simply missing. It was there, billions of miles from its home planet, that Voyager 1 detected a persistent hum coming from an unknown source, which most likely originated from interstellar space. During its 4 decades of travel, the spacecraft had recorded various signals, but this was the first time it encountered something like this. And considering that Voyager 1 is literally feeling its way through regions that the entire solar system, led by its star, will eventually pass through, the information it has gathered becomes especially relevant. Would you like to learn more about what Voyager 1 is studying? Our planetary system, centered on its parent star, lies inside a giant bubble called the Heliosphere. All the planets of the solar system, along with the Kuiper Belt, are under the protection of this invisible shell. It reliably shields these objects from the hostile interstellar environment. So, what is the Heliosphere and what are its characteristics? It is a vast region where the solar wind plasma moves at supersonic speeds. At the boundary with interstellar space, the solar wind collides with the plasma and magnetic field of interstellar space. To put it simply, the solar wind accelerates to high speeds, twists into a spiral, and then suddenly slows down as it hits an invisible barrier and gradually mixes with cosmic particles. Voyager 1 is currently located in the region where these events are unfolding, which means that's exactly where the spacecraft detected the mysterious signal. How difficult was the journey of the spacecraft before it reached the outskirts of the solar system? Where did the probe travel and what stages has it already passed? In 2004, Voyager 1 crossed the termination shock, a region of the Heliosphere where the solar wind begins to slow down significantly in anticipation of encountering interstellar matter. How did scientists on Earth learn about this? Of course, the conclusions are based on the readings from the spacecraft, the space probe. Yes, as mentioned earlier, after 43 years it is still sending signals, although not all the sensors on board the spacecraft are working properly. Anyway, let's continue. Beyond the termination shock lies the Heliopause, where the solar wind finally calms down and mixes with the matter of deep space. The structure described is known to astronomers indirectly, since apart from Voyager 1, no other inhabitant of Earth has ever ventured so far into the impenetrable darkness of the universe. That makes its message all the more valuable to us. For example, there is a hypothesis that beyond the heliosphere, at the solar system's boundary known as the bow shock, there is a hydrogen wall filled with hot gas. Could that be the hum Voyager 1 transmitted to us? The signal consists of vibrations in a certain frequency range and could very well serve as confirmation of this theory. Unfortunately, it's impossible to measure the pressure, density, or temperature of the plasma because the instrument on Voyager 1 stopped working back in 1980, 3 years after launch. But the other instruments are still active and scientists rely on them. The plasma wave instrument and the cosmic ray detector are still diligently sending us information. Thanks to the latter, it was possible to record an increase in the level of cosmic rays and high-energy electrons when Voyager 1 was approaching the boundary of the heliosphere, which it successfully crossed on August 25, 2012. The probe's power supply is provided by radioisotope generators running on plutonium-238. At the moment, their power has decreased by half. But let's return once again to the mysterious hum detected by Voyager 1's instruments. What hypotheses, besides the ones already mentioned, do scientists consider to explain this strange phenomenon? The fact is that similar vibrations are also caused by plasma waves of various origins. For example, they can be triggered by large solar flares. Some astronomers suggest that the space at the boundary between the solar system and outer space has a structure similar to foam. This happens because small cosmic objects form small spheres around themselves, similar to magnetic bubbles. It is possible that this also leads to the appearance of strange vibrations detected by Voyager 1. By the way, the sound of the mentioned signal is similar to a distant ringing, periodically interrupted by strange irregular bursts that resemble the striking of a bell. It gives the absurd impression that someone is sitting astride the space probe and banging on its hull. Has the human-made spacecraft left the solar system for good? Not at all. According to NASA's calculations, this will happen in about 30,000 years. Right now, the probe is passing through a kind of cosmic circle of hell, but unlike the companion in Dante's Divine Comedy, the spacecraft is completely alone and has no companion whatsoever. The boundaries of the solar system extend much farther than the Kuiper Belt and even the Heliosphere. It will take about 3 centuries, and Voyager 1 will plunge headlong into the Oort cloud, if it actually exists outside of scientists' imagination, since no one has ever actually seen this formation. It is believed that the comets that sometimes enter the solar system are actually visitors from this very cloud. So what will happen next? As soon as Voyager 1 leaves the boundaries of the Titanic Torus, the spacecraft will embark on an eternal journey through the Milky Way, and we are unlikely to ever learn of its fate unless the golden record with Earth's sounds and other information falls into the hands of extraterrestrial civilizations. Unfortunately, modern astronomy is in many ways like reading tea leaves, although of course the science of stars has advanced significantly compared to previous centuries. It's hard to imagine what else Voyager 1 will discover on the outskirts of the solar system. And most importantly, how can we decipher these signals? For now, the spacecraft is about 20 billion kilometers from Earth, cutting through space at a speed of 60,000 kilometers per hour. Its research is very valuable for science because thanks to it we can lift the veil of mystery a little and learn what interstellar space is made of and how it behaves in its natural environment. In addition, this will allow us to take past mistakes into account when designing new probes that will be even faster and more reliable. And while Voyager 1 literally has a ringing in its ears, let's enjoy the comfortable conditions on Earth and the ability to easily get any information about the vastness of space without leaving our favorite couch. Earth is the perfect planet for humanity to live on. Do you agree with this statement? It may seem that it is obviously true, but things are not so clear-cut. Indeed, considering our planetary surroundings, Earth seems like a unique island of life and natural abundance. But is the universe really incapable of creating something more perfect for the existence of the human race and the emergence of life in general? Undoubtedly, it is capable. It's just that, due to our technical limitations, we are not yet able to discover such objects. Although, there are still a few planets we have in mind. But first, we should decide which characteristics of Earth need to be improved so that we can live even more comfortably. What should our planet be like? Should it be warmer, more humid, larger in size? Maybe it would be better to warm it with a different type of star. Tasks like this, with the appropriate parameters, will soon be delegated to the newly launched James Webb Telescope. But scientists have different goals. To find out which exoplanet would suit us better than Earth, let me give you a little spoiler. Later in this episode, we'll talk about the objects that have already been found as candidates for this role. By the way, a signal was received from one such planet, Gliese 581d, a few years ago. Scientists are still debating how to interpret it, as white noise or maybe as a greeting from an alien civilization. The object is located in the constellation Libra, about 20 light-years from Earth. Astrobiologists from Queen Mary University and the University of Hertfordshire believe that the planet could very well be habitable, despite the fact that Gliese 581d is located on the edge of the Goldilocks zone of its parent star. The received signal was very cyclic and orderly, so there is every reason to believe that it has an artificial origin. So, what should we pay attention to first when searching for ideal exoplanets? The star that illuminates them. Our Sun is a G2V star, or a yellow dwarf. Compared to the unstable and unbalanced brown or red dwarfs, it is much more stable. There are stars in the universe with even more suitable characteristics. For example, K-type stars. Their lifespan reaches up to 70 billion years. That's 7 times longer than the Sun's. Stars of this type include orange stars, from dwarfs to supergiants. The temperature on their surface does not rise above 5,000 Kelvin. For comparison, some areas of the Sun heat up to 1,520,000 Kelvin. Not to mention the corona, where monstrous temperatures reign, reaching up to 20 million Kelvin. In terms of composition, such stars are somewhat similar to G-type stars, but there is little hydrogen in their cores. Remember the history of our planet. What cataclysms has it gone through during this time, and why? Many of them happen because of abnormal solar activity. With K-type stars, there are no surprises like ice ages or planet-wide droughts, because their lives are smoother and more balanced. Accordingly, the planets nearby have a much more comfortable existence. That's why members of the SETI projects mainly search for extraterrestrial civilizations near orange dwarfs. Are there many such stars within the Milky Way? Scientists say the number is just over 15% of the total number of stars. As an example, we can mention Alpha Centauri b, which is located 4 light-years from Earth. But what about the planet itself? What characteristics should it have to become the best candidate for life? First of all, we indignantly rule out celestial bodies that are too old. Geological processes on them slow down over time, as a result of which the magnetic field may disappear completely. The latter statement means one thing: humanity, or whoever lives on this planet, will very soon turn into a handful of people dying from radiation sickness as cosmic rays freely reach the surface. So what is the optimal age of an exoplanet that could become our new cradle of life? Approximately 58 billion years. That is, essentially, it should be about the same age as Earth or a little older. This factor is also related to the evolution of species, which needs time to develop. Remember how long it took for Earth's microorganisms to evolve from a vague primordial soup to upright humans, and even more so to intelligent beings. According to rough estimates, this process took 3.7 billion years. It is also necessary to take into account the time required for the formation of the planet itself. If you add the lifespan of the star to this scheme, as well as certain periods of its development, the ideal formula becomes much more complicated. Now let's talk about size. Do they matter? In the case of exoplanets suitable for life, yes. For example, it is believed that celestial bodies that are 10% larger in volume than Earth are an excellent option in this case. Why? First of all, such planets have stronger gravity, which means they can hold on to their atmosphere much longer than Earth. Current data shows that our planet is losing its atmosphere at a lightning-fast rate compared to neighboring celestial bodies. Explaining what this could lead to is likely unnecessary. The heat of the core also directly depends on the size of the planet. Larger objects retain it for a longer time. Now let's turn to more specific characteristics, such as the planet's surface temperature and humidity. Remember which regions of the Earth are most densely populated with living organisms. Absolutely right, it's the tropics. By analogy, we can assume that hotter and more humid planets have a high chance of developing complex and diverse forms of life. What is the average temperature of the Earth? It is about plus 14 degrees Celsius. Add just about 5 more degrees, and the planet will be close to perfect. However, you have to consider an important fact. All of this is true only if there is water. From this statement follows the next point. The smaller the continents, the higher the chance for a diversity of life forms to emerge, because the likelihood of uninhabited desert regions forming decreases. We have listed the approximate set of parameters that James Webb will rely on when searching for potentially habitable exoplanets. He will also be assisted by 2 important indices: Earth similarity and planetary habitability. By the way, the latter takes into account a wider range of objects where life could develop based on other chemical processes. For example, it could arise on objects that are hotter or much colder than Earth. But that's all theory. But what about in practice? There are already real candidates for this vacant position, and the first of them is Kepler 442b. The huge planet is located in the constellation Lyra, quite far from Earth at a distance of 1,120 light-years. It orbits right next to an orange dwarf of spectral class K. Its size is also similar to Earth's, but on the larger side. Kepler 442b is 1.3 times larger than our planet. Needless to say, this planet is located in the Goldilocks zone, that is, in the habitable zone around its star. Thus, the conditions on it could very well be close to those on Earth. The next candidate for the title of ideal Earth is the planet TRAPPIST. One eye? However, the star that gives it light is a red dwarf, and those are pretty unpredictable guys. The exoplanet is located in the constellation Aquarius, and its diameter is close to that of Earth. If this planet has a dense atmosphere, then there could very well be water too. And where there's water, there's life. at least in the forms we are familiar with. Is there a list of habitable planets? Yes, it has been compiled, although there isn't much data. In addition to the mentioned objects, it includes Gliese 667, C. Kepler 296, E. T. Garden B, and others. But astrobiologists often ask themselves an uncomfortable question. Does life really have to be like it is on Earth? Does it necessarily have to develop according to the known laws? What about alternative biochemistry? In that case, the list of exoplanets could be expanded endlessly. However, let's temporarily ignore these statements and summarize what was said above. What are the main criteria for habitable planets? And in what cases could they even be better than Earth? The first factor is the energy source. This refers to the parent star, including the distance to it and the type of object, as well as the internal resources of the celestial body. Let me remind you, orange dwarfs are considered ideal here. The second factor is the presence of water in an atmosphere. The third factor is the planet's characteristics, such as its mass, geochemistry, orbit, and rotation parameters. The galactic environment of the object is also important, because if there is a supermassive active black hole nearby, a supernova occurs, or there is a source of powerful gamma radiation that sterilizes everything in its path, then the chances for life to develop are extremely small, no matter how perfect the other conditions are. Anyway, despite the lengthy discussions of astrobiologists, for now, Earth remains the perfect home for humanity. Of course, this doesn't prevent us from searching for something new and possibly better. Tell me, would you like to change your address on a planetary scale? For example, would you want to move to Mars for good once it's been upgraded? Or to distant Kepler B? It's quite possible that when geopolitical conflicts settle down, pandemics subside, and financial crises are resolved, humanity will do just that. But not today, my friend. Not today. Nuclear war became a realistic nightmare for humanity from the moment the world realized the level of danger posed by weapons of mass destruction. Since then, people have been coming up with questions, each more intricate than the last. For example, is it possible to blow up the moon? Or what would happen if we triggered the simultaneous detonation of our entire nuclear arsenal? To begin with, let's find out what humans are like, what assets we have. There are currently 15,000 nuclear warheads stored on the planet, most of which belong to the United States and Russia. With that number of bombs, if desired, you could pile up an island the size of Manhattan and build all the world's known skyscrapers on it. But let's move from colorful comparisons to the grim reality. Let's suppose that this deadly wealth is gathered in one global hangar. Imagine that the presidents of the world's powers have gone mad and decided to blow it up. How devastating would the consequences be? To begin with, let's start with a brief reminder of a well-known fact. In 1983, the Indonesian volcano Krakatau erupted, claiming the lives of 36 island inhabitants and almost destroying the archipelago. The force of the explosion was equivalent to 200 megatons of TNT. For comparison, a Minuteman III warhead has 300 kilotons. As a result, within a radius of 250 kilometers, due to the rapid release of dust up to 80 meters high, day literally turned into night. The shock waves circled the globe several times, and the sounds of the eruption were heard at a distance of 5,000 kilometers. Why do we need this information now? There are 4,500 cities on Earth, each with a population of about 100,000 people. Of course, there are smaller and much larger settlements, but we'll take the average value. It would take just 3 bombs to destroy each of them. So, by dropping the warheads at once, you could make all the cities instantly blow up, leaving not a single stone standing in their place. Half of the world's population would disappear in an instant. And after this single strike, we would still have 1,500 warheads left in reserve. That's just a warm-up. The question is, what would it look like if 15 warheads detonated at the same time? If they all explode together, the warheads will create the effect of 15 Krakatoa eruptions. The scene will be so terrifying and grotesque that witnesses to the event will most likely not believe their own eyes in the first moments. Instantly, as if from underground, a dazzling fireball with a diameter of 50 kilometers will rise, and the shock wave will immediately destroy buildings, trees, and everything else within an area of about 3,000 hectares. Everything within a radius of 250 kilometers from the epicenter of the monstrous explosion will burn. The shock wave will circle the globe for weeks, and its audible range will not be limited to 5,000 kilometers, as it was during the Krakatoa eruption. The sound will be clearly heard in every corner of the Earth. All of this will happen instantly, but what will happen next? For events of this kind, even those much smaller in scale, the worst happens later. That's when the living begin to envy the dead and regret not having received instant death, ending up with a painful and slow demise instead. And here's what will happen next. A nuclear mushroom cloud will rise up to 50 kilometers and reach the stratosphere, so the explosion will be felt even by an astronaut. A scar in the form of a crater about 10 kilometers in diameter will remain on the surface of the Earth. Fires will engulf the affected area. Radiation will spread across the planet and begin to take its terrible toll. The number of cancer cases will sharply increase, and those who do not die from the listed disasters will face a prolonged nuclear winter. And that means mass starvation, terrible diseases, and the extinction of most of humanity. Obviously, nuclear weapons are one of the most nightmarish and destructive inventions. But is it capable of destroying an entire planet? The answer is not definitive and goes like this: both yes and no. This question was raised by physicists and volcanologists who came to ambiguous conclusions. First of all, the huge stone sphere with a diameter of 12,742 kilometers, which is our Earth, cannot be destroyed even by the current nuclear arsenal. This won't happen even if we extract all the uranium from the Earth's interior and make 10 trillion bombs equivalent to those dropped on Hiroshima. Secondly, if we are not able to split the Earth, then, as physicists claim, it is theoretically possible to shift it from its orbit. For example, by stopping the planet's rotation. Scientists have calculated that to do this, it would be necessary to simultaneously detonate 600 quintillion, that's a number with 18 zeros, bombs, each with a yield of at least 1 megaton in TNT equivalent. In that case, the Earth would most likely stop and fly toward the Sun, since our star is the closest object with significant gravity. This, of course, would mean the certain destruction of the planet. Volcanologists, however, do not share the physicists' confidence and insist that if even the eruption of the Yellowstone supervolcano, which has erupted 142 times over 17 million years, could not knock the Earth off its orbit and send it toward the blazing solar corona, then it is highly doubtful that humanity could achieve such a thing. Moreover, it's hardly realistic to create enough bombs that could destructively affect the rotation of our planet. But any arguments pale in comparison to the following fact. Every single scientist, regardless of their specialization, says the same thing. It is necessary to drastically reduce the buildup of arms, because we are sitting on a powder keg that could explode at any moment and kill its creators, as well as billions of their fellow human beings. Think about it. Even a nuclear conflict between small countries would have planetary consequences, resulting in lasting climate change, the emergence of mutations and incurable diseases, as well as widespread famine. A large-scale war between superpowers would almost certainly result in humanity being thrown back to the Stone Age. With that in mind, the Hubble channel invites everyone to vote. Write in the comments whether you agree with the need for total disarmament of the nuclear powers, and be sure to explain your opinion, whatever it may be. We look forward to a heated debate on this crucial issue that concerns all of humanity. And more likes on this video will let us know that we are moving in the right direction with our episodes, and will motivate us to make each video better and better for you. So don't hesitate to click that mouse button and give us as many electronic thumbs up as you can. See you